isentropic or the reversible adiabatic process. We have the definition, it is an internally reversible constant entropy naman, kaya tinawag na isentropic process. Okay, so simulan natin. We have the first type of formulas. Okay, so PVT relation, wherein entropy is constant, or pwede na sabihin PV raised to K is constant. So ito yung formula natin. We have first the pressure-volume relation. Next, we have the temperature-volume relation. Then, we have temperature-pressure relation. So, dun sa pressure-volume natin, dun lang natin sundan sa constant, PV raised to K. Then, temperature-volume, makikita natin subscript, pareha sa taas ang 0.1. Nasa baba ang 0.2. Kaya ganun na lang natin siya tandaan para di malito sa numbering. And then, exponent is 1 minus K. Ganun din sa temperature-pressure, yung subscript, magkatapat lang. Then, ang exponent, K minus 1 all over K. Then, next, we have the PV and TS diagram. So, PV diagram, nakakurba siya pababa. And TS diagram, pababa siya. Kasi nga, constant entropy. Then, we have the work non-flow. Then we will arrive the formula work non-flow P2V2 minus P1V1 all over 1 minus K. Then sa steady flow, ayun yung ating general formula. Work steady flow na K, then P2V2 minus P1V1 all over 1 minus K. Kaya mapapansin natin, ang work steady flow is K times the work non-flow. Pwedeng ganun. Then, ito pa yung ibang formula natin. Change in internal energy. Ganun pa rin. mcv delta T. Balik na tayo. Then, ang change in enthalpy. mcp delta T. Ang heat natin ay 0. Kasi nga, nabanggit natin, pag adiabatic, okay, no heat transfer. So, 0 yan. Then, change in entropy, syempre, constant entropy yan. So, 0 yun. Problem 13. Nitrogen is expanded isentropically. Its temperature changes from 620 degrees Fahrenheit to 60 degrees Fahrenheit. Find the pressure ratio. Given is nitrogen, we have value of K 1.4. Entropy is constant, binanggit isentropic. Temperature 1, 620 degrees Fahrenheit. Temperature 2, 60 degrees Fahrenheit. Ang hinahanap ay pressure ratio. That is pressure 1 over pressure 2 according dun sa problem. So for our solution, ito ang formula na gagamitin natin, isentropic. Since binigay sa problem na yung temperature, hinahanap ang ratio ng pressure, relationship nila, ito. Okay, so kung babasahin natin, is Tito, Pepito, Kick. K minus 1 over K. Substitute. Take note, ang temperature should be in absolute, so dapat parehas may plus 460 sa solution. Now, our pressure ratio, or the ratio of the pressure, is 12.91. Nitrogen is expanded isentropically. Its temperature changes from 600 degrees Fahrenheit to 60 degrees Fahrenheit. The volumetric ratio is volume 2 over volume 1 equals 6.22, and the value of R for nitrogen is 0.07087 BTU per pound mass Rankine. What is the work done by the gas? Okay, meron tayong given nitrogen gas ulit. Ang K is 1.4. So, binigay na yung gas constant. Tingnan natin pakukunin. We have 0.07087 BTU per pound Rankine. Sinabi rin constant entropy. Then, temperature 1, 600 degrees Fahrenheit. Temperature 2, 60 degrees Fahrenheit. And meron tayong volumetric ratio, 6.22. Okay, ang required is the work. Okay, so hindi natin alam kung non-flow or steady flow. So, ang assume muna natin is non-flow. So, kumbaga yun yung default natin pag hindi natin makikita sa problem. Or walang mga component na nag-identify kung anong klaseng flow. So, for the formula ng non-flow, we have P2V2 minus P1V1 all over 1 minus K. Eh, wala tayong P2, V2 at P1, V1. So, ang gagawin natin, pwede natin siyang palitan in terms of temperatures. Kaya lang, tanda natin, hindi lang naman yun yung formula ng work non-flow. Nabanggit natin, pwede natin gamitin ang formula ng first law. Since non-flow tayo, ang formula ng first law is heat equals delta U plus work non-flow. Eh dahil adiabatic ang isentropic, so heat is 0. So lalabas ang work non-flow natin, pwede natin palang sabihin that is equal to negative delta U. Pwedeng gano'n. So, wala namang mass na binigay, so alisin lang natin yung mass, meaning specific tayo. So, diretso na natin. So, yan na yung magiging formula natin. So, we have the work per unit mass. So, equals negative CV T2 minus T1. Okay, wherein ang CV is equal to R over K minus 1. So, diretso na natin substitute. We have work non-flow. Okay. Cancel ang ating run-kind. So, we have the answer 95.67 BTU per pound. How much work is necessary to compress air in an insulated cylinder from 0.20 cubic meter to 0.01 cubic meter? Use temperature 1, 20 degrees Celsius and pressure 1, 100 kilo Pascal. So, ito yung mga given natin. We have the air, K is 1.4. Merong sinabi sa problem, insulated. Pag sinabing insulated, no heat transfer, therefore, constant entropy. Okay, so sinabi rin yung cylinder, so non-flow tayo. Volume 1 is 0.20 cubic meter. Volume 2, 0.01 cubic meter. Temperature 1, 20 degrees Celsius. Pressure 1, 100 kilo Pascal. At ang required ay work non-flow kasi nga cylinder. So, formula natin is P2V2 minus P1V1 over 1 minus K. Wala tayong pressure 2. So, kukunin natin ang pressure 2 in terms of the relation ng pressure and volume kasi yun yung meron sa given. Dalawa yung volume, tapos pressure, yun yung hinana. So, substitute natin muna. Lalabas ang pressure to 6,628.91 kilo Pascal. Then, substitute natin dito sa ating original working equation. Hindi na natin lalagay pa yung unit kasi SI naman lahat. Ay lalabas ang work, negative 115.72 kilojoule. Air undergoes an isentropic compression from 14.7 psia to 180.6 psia. If the initial temperature is 68 degrees Fahrenheit and the final temperature is 621.5 degrees Fahrenheit, calculate the work done by the gas. Given, we have air with the value of K 1.4, pressure 1 14.7 psia, pressure 2 180.6 psia, temperature 1 68 degrees Fahrenheit, temperature 2 621.5 degrees Fahrenheit. Ilagay na rin natin sa given ang R 53.34 foot-pound force per pound mass run-kind. Okay, kasi English units tayo. So, required is the work non-flow. So, lower case yan kasi walang binigay na mass or walang total na properties doon sa given. Kaya specific. And at the same time, non-flow, yun yung default natin. Wala naman rin binanggit sa problem tungkol doon sa klase ng equipment. So, for the formula, itong formula natin. So, dapat specific. So, if this is specific in terms of work, specific volume gagamitin natin. So, walang volume sa problem. Kung walang volume, pwede natin palitan ang pressure volume. Take note, yung pressure volume natin, pwedeng ito ang formula. Dahil specific, wala ng mass. So, PV equals RT. So, now, yung ating working equation, magiging ganito na yan. Lalabas yung R kasi constant, so that would be change in temperature. So, wala nang problema kasi meron na sa problem. So, ito na yung working equation. Substitute na lang natin. Ay, yung change in temperature, no need to convert in absolute kasi change nga yan. Pwede nang change in arbitrary temperature din yan. So, our work non-flow now is negative 73,809.22. Unit is foot-pound force per pound mass. Problem number 17. Air having an initial pressure of 6,516 kilopascal and an initial volume of 0.113 cubic meter is compressed adiabatically to a final volume of 0.057 cubic meter. Calculate the pressure at the end of the compression. Given, we have air, K is 1.4 pa rin, pressure 1, 6,516 kilopascal, volume 1, 0.113 cubic meter, volume 2, 0.057 cubic meter. Ang hinanap ay pressure 2. So, for our formula, may sinabi sa problem na adiabatically. Okay, when you say adiabatically, no heat transfer. So, no heat transfer, yan ay possible na mangyari lang sa isentropic process. Kaya, ang solution natin dito is isentropic. So, ito yung relationship ng pressure-volume pagdating sa isentropic. So, given na lahat, alam na naman natin yung value ng K. Let's say, substitute. Lalabas ang ating pressure to 16,985.02 kilopascal. During an isentropic non-flow process with air, the pressure drops from 60 psia to 20 psia. The air has mass of 0.10 pound and the initial temperature was 280 degrees Fahrenheit. Question, find the final temperature in degrees Fahrenheit. So, yung mga given natin, we have isentropic, so constant entropy. Pressure 1, 60 psia. Pressure 2, 20 psia. Air na may K na 1.4. Temperature 1, 280 degrees Fahrenheit. Ang hinahanap ay temperature 2, arbitrary. So, unit ay degrees Fahrenheit. Ang formula natin, dahil ang given merong dalawang pressure, hinahanap ang temperature, so ito yung formula natin, based on isentropic. Then, substitute lang natin. Take note, dahil ang hinahanap ay arbitrary, so yung absolute nating T1, T2, sa solution natin, meron nakalagay 280 plus 460 kasi nga kailangan sa formula absolute. Then sa denominator, meron tayong arbitrary temperature 2 plus 460. Para pag kinumpute, ang lalabas na agad ay arbitrary na. So we have temperature 2, 80.64 degrees Fahrenheit.